Alright, this video goes with the Unit 4 test prep to prepare yourself to pass the Unit 4 test. So, we're just going to go one question at a time. You need to press pause when I go too quick. Try your best, then press play to see if it follows or just follow what I'm doing. So we're just going to go one at a time. Number one. And again, there's not enough room on the piece of paper to do the work on the piece of paper, so you need to do the paper work on a separate piece of paper. So number one says analyzing graphs. So you're given a function y equals 2x cubed minus 3x squared. So define intercepts, increasing, decreasing, concavity, and so on. So we're just going to go one at a time. If I want to find the intercepts, the x-intercepts, make it equal to 0, and solve for x. We're going to solve this by factoring. So we're going to factor out an x squared, be left with 2x minus 3. If you take each factor equal to 0 and solve, one is going to be 0, and the other answer is going to be add 3 divided by 2. So if I ask for the zeros, I know at 0 it's going to, here it's in factored form, so at 0 it's going to touch because we have an even exponent, and at 3 over 2 it's going to, which is 1.5, it's going to cross. Multiplicity from last year. What else? Y-intercept. Wherever there's an x, put in 0, so the answer is 0. If you look, just put in 0, so the y-intercept is 0. To find increasing and decreasing, take the derivatives. That's 6x squared minus 6x. Make it equal to 0 to find the critical numbers. So divide out 6 and an x. Solve it. So each factor has an answer. So one answer, 6x, gives you the answer 0. X minus 1 gives you the answer positive 1. We're going to do a first derivative number line using 0 and 1. If you plug in a number smaller than 0, the answer is positive. If you plug in a number between 0 and 1, like 1/2, the answer is negative. And then any number bigger than 1 will give you a positive answer. That means it is increasing from negative infinity to 0. It's increasing from 1 to infinity. It's also decreasing from 0 to 1. This is going to create a max. This is going to create a min. So we already know there's a relative max when x is 0. If you plug 0 back in, you know 0, 0, the y-intercept is a maximum. The minimum is at 1. And if you plug 1 back in, you get the answer negative 1. So we already have a relative max and min. We know where it's increasing and decreasing. What do we still need to do that we haven't found is concavity. So to find the concavity, take the first derivative and then take the derivative of that to get the second derivative. That's 12x minus 6 equals 0. If you solve it, you add 6 divided by 12. It's actually 1/2. Again, plug in any number less than 1/2 and the answer is negative into the second derivative. Plug in a number bigger than 1/2 into the second derivative. The answer is positive. So we know it's concave up from 1/2 to infinity. It's concave down from negative infinity to 1/2, and that there's a point of inflection at 1/2. If you plug in 1/2 back into this equation and you do your best to focus in to get the y coordinate here, make sure that it's lower enough so you can see it. So this is 1/8. This is 1 over 4. 2 goes in 8, 4. 3 times 1 is 3, so that's negative 2 over 4. So you can see it's negative 1/2. That's it. So then we graph it. So what points do I care about? 0, 0. We have a minimum at 1 and negative 1. And then at 1/2 and negative 1/2, there's a point of inflection. So the first part is increasing concave down. So it's concave down to 1/2 and increasing, and then after 0 it decreases. It continues to decrease, but now it's concave up. It's be able to see both at the same time. So it's concave up. Remember the other x-intercept is at 3 over 2, which is 1.5, so right there. So it's going to be concave up, and you've analyzed and graphed it. Concavity, increasing, decreasing, increasing, max, min, and all of it. All right, that's number one. Number two. You're given a graph, number 2, and it says what it's given is y prime. So I'm going to first do a y prime number line. And what I'm looking at off the graph, here, I'll show you the graph here. for y prime is I'm looking for the intercepts. At what numbers are the intercepts? So I'm going to pull them off. That's negative 2, 1, and 3. So negative 2, 1, and 3. And then I look off the graph where it's above and below. So it's below, then above, then below, and then above. So that tells me, for the y, it tells me increasing and decreasing. If I want to do the second derivative, I'm looking at maximums and minimums. So at what x value do we have a maximum? At 1. And where's the minimum? At 2. So at negative 1 and at 2, we look at it. And then I'm looking, where is it increasing or decreasing? So it increases. Then from negative 1 to 2, it decreases. And then 2 on, it increases. So then I found out concavity and where it's increasing and decreasing. So at negative 2, at positive 1, at 3. So no, at x equals negative 2, and at 3 we have minimums. At x equals 1 we have a relative maximum. Alright, so I'm going to sketch it. So now I have enough information. It doesn't give me an anchor point, so I'm just going to pick an anchor point to go with. So I know negative 2 all the way to 3. So at negative 2 we have a minimum. I'm just going to pick a point to anchor it to. I know it's concave up and it's decreasing. And it stays concave up to negative 1. So I'm going to do another one. It's concave up. I know that at negative 2 it's a minimum, so I just put a point higher than that, and that I just stop there. So concave up. Then it's going to be concave down, and at positive 1 there's going to be a maximum, and that ends at 2. And then after 2, it's going to be concave up again at 3, and you can, whatever you want to think, 3. So concavity and minimums and maximums. All right, number 3. This time in number 3, and again, press pause, try it, read it over, and then press play so you have a good sense of it. All right, in this one, so you're given the y. So you're given that, and you're supposed to sketch the derivatives. So I'm going to do a y prime number line. When I do the y prime number line, I'm looking at maximums and minimums. So for this case, when I look at it, where's the maximum minimum? So there's a maximum at negative 2 and 1 approximately at 1. And I know that it's increasing, then it's decreasing, then it's increasing. If I looked at the concavity, I know you're estimating here, but it's concave down, and then somewhere here it changes from concave down to concave up. So approximately, what's the x value of the point of inflection? And again, it's concave down, then concave up. And so what would the graphs look like then? So let's start with y prime. Negative 2 and positive 1 are intercepts then. At negative 1 approximately, there's a point of inflection. That's going to be like the bottom, the vertex. For the first derivative goes with the point of inflection. For the second derivative, if I look at the second derivative, so notice it's above, then it's below, and then it's above. Negative 1 for the second derivative. There's the intercept. Just know it goes from, this is parabolic. This is going to be a line, a slanted line. Every time you take the derivative, the degree is less. You can think of this as x squared, and this is x, and what the original was like x cubed. And you can see it goes below to above, and those are sketches of derivatives. Number 4. So when I look at number 4, you have the first derivative at negative 1 equals 0. The first derivative at 3 equals 0. The first derivative of 5 equals 2. That's just telling me at 5 it is increasing, not a critical number. And so those are the only ones. So when I do a number line, -1 and 3, because it's equal to 0, those are critical numbers. So 5 is positive number, so I know past 3 it is increasing. Some other information. It says at 3, the second derivative is greater than 0. I'll go to -1, 2 in a second. That just means the concavity is positive, which means it's concave up, which means there's a minimum at 3. For there to be a minimum at 3, then this must be negative, so it creates a minimum. It says the second derivative at -1 is less than 0, so that is concave down. So concave down, if this was concave down, then that must be positive to create concave down. So already we did a first derivative number line. The second derivative number line, where's the second derivative equal to 0? So the second derivative is equal to 0 at 5. Where else? And the second derivative at 0 is equal to 0. What do we know about the concavity? So it says at 3 it's positive. It says at -1 it's negative. And then anything past 5, are you given any information about concavity past 5? Whether it's concave up or concave down. So it says when the second derivative is greater than 0 when x is greater than 5. So if that's the case, then it's also concave up. Okay. Sketch it. So sketch the function. So it gives you a point, right? 0, 0. So there's a point to anchor to. We have -1, we have 3, and 5. So there's a point. What happens at -1 and at 0? So at 0, the concavity changes from concave down to concave up. So first of all, it's increasing, then decreasing. So I'm going to create a point here. So it's increasing, then decreasing. And it's concave down all the way to 0. Then from 0 to 5, it's going to be concave up. And at 3, there's going to be a minimum. So concave up. And then after 3, it increases. And if you like, and it says at 5, it continues to be concave up and increasing. All right, number 5, find the y values where there's vertical tangents. So you're given something that is implicit, and can you derive implicitly? So let's do it together. This is a prior unit. So the derivative of x squared is 2x. The derivative of y squared is 2y, but you need the hook y prime. The derivative of 2x is 2. The derivative of 2y is 2y prime, and then the derivative of -1 is 0. We need to get y primes on one side, and whatever doesn't have a y prime on the other side. So 2y, y prime will stay. We're going to subtract 2y prime, and then on the other side we have -2x plus 2. Now we're going to factor out y prime. That leaves me with 2y minus 2. Then to get y prime by itself, we're going to divide. Now the question is, where are there vertical tangents? So a vertical tangent means that we have a vertical line. That means the slope is undefined. That's important. So derivative means slope. Vertical tangent means the slope is undefined. You have a fraction. What y value makes it undefined? So it's the bottom. And the bottom cannot be 0. So if you solve it, at what y value is the vertical tangent undefined? And the answer is at y equals 1, because that makes a 0 on the bottom. All right, number 6. So number 6 gives you a function ax squared plus bx. And it says there's a relative max, there it is, at -1, -4. So what we're going to do is find what values for A and B make that true. So first of all, you're given a point. So the y coordinate is -4. We're going to create a system ultimately. So the y coordinate is -4. The x is -1. Simplify it a little bit, and I get A minus B. Now, if it's a relative max, when you take the first derivative, which we will, it's 2ax plus b. And again, if you plug in -1 for x, the answer is actually going to be 0 because it's a critical value. So simplify that over here. This is -2a plus b. Now we have a system we can solve, so we're going to add it together. Notice a -4 plus 0, a plus -2 is -1a, the b's cross out, divide by -1, and a is equal to 4. To find b, you go back into either equation. So if you go back to the top where there's an a, put in 4, and then solve for b, so subtract, divide by -1. So what are your two values? A is 4 and b is 8. Number 7. In number 7, sketch f at x where f at x is continuous. F at 1 equals 1, so f at 1 equals 0. So we have a point at 1, 0. It says it's continuous, so there's no breaks, no holes, anything like that. And we're just going to follow the information. So it says f at x, the function, is less than 0 everywhere but 1. So at 1 it's 0, but everywhere else it's going to be below the x-axis. That's what that means. So if the function is less than 0 everywhere, that means it's below the x-axis. It doesn't include 1 because at 1 the answer is 0, which is neither positive nor negative. So the whole thing is going to be below the x-axis except at 1, 0. Then if you keep reading, it says the derivative is positive. No, derivative f at x is less than 0. So that means it's decreasing. When is it decreasing? When x is bigger than 1. So decreasing after x equals 1. What else does it say? Well, the derivative is increasing. So it's positive, so it means it's increasing. When? When x is less than 1. So that means before 1, it's increasing. It says the derivative doesn't exist at 1, which probably means there's a cusp or a corner because it's continuous. It says the second derivative is greater than 0, which means concave up, positive. For when? Between -3 and -1. Between -1 and 2. So this is where it's concave up, where it's going to smile. Then it says the second derivative is less than 0 when x is less than -3 and x is greater than 2. That's concave down. So let's do number line before we do the graph, based on what we just said. So first derivative number line. The key number here after 1 and before 1, increasing, decreasing. So 1 is a critical value. And it says and then what's happening before 1? It's increasing, and after 1 it is decreasing. For the second derivative, we have a few numbers, -3, -1, 2. And so it's concave up between -3 and 1, between -1 and 2. That's this right here, concave up. When it's less than -3, it's down. Bigger than 2, it's down. Now we're going to sketch this. So the whole sketch is below the x-axis, so that's why I'm going to draw it like this. I know there's a point at 1, 0, so I'm going to do that. And I have values that I care about, at -1, at -3, at 2. So what's happening to begin with? So before 1, it is increasing. Here, increasing. So it's increasing with a frown up to -3. So increasing up to -3 with a frown. From -3 to -1 is a +1. Where is it? From -3 to -1. Oh, from -3 to -1, it is smiling and still increasing. In fact, here it's concave up and it's still increasing. So concave up and increasing all the way to 1. After 1 it's going to go down, but it's still concave up all the way to 2. So can you see the cusp there, that it's concave up, and then it's going down, and it continues to go down, but this time instead of smiling, it's going to frown going down. So can you get the shape of the concavity increasing and decreasing to be able to sketch what's being said? All right, that's number 7. Number 8. In number 8 it says a function is differentiable and it has critical numbers at 1, 3, and 8. So there it is, 1, 3, and 8. It says the second derivative at 8 equals 0, which means it could be a point of inflection there. There's a second derivative at 3 is less than 0. So if I do a second derivative number line, 8 is on there. At 3, it's less than 0. So here 3 is, right? It's just telling me that it's negative before 8. So when you plug in 3, any number before 8, when you plug it in, the answer is negative. The second derivative at 1 is greater than 0. Oh, I need another point of inflection. So it says it's 0. There's another one. Now, I think there's a typo here. I think that they really meant to say that this is not +1, but I think this meant to be -1, because we need information to the left in terms of understanding it. So it says the second derivative at 3, the second derivative at 2, but yet the points of inflection, or the critical numbers for the second derivative, are at 8, and the second one is at 0. And then they give you information between 0 and 8, like 3 and 2, and they're opposite information. So one says it's negative, the other says it's positive, and that's between 0 and 8. So 8 obviously needs to be written better. So we're going to cross out 8 and go to 9, because the information, there's some typos there. So I need to go back and understand the typos and then redo it properly. So let's move on. Number 9. The slope of the curve is given by the derivative dy by dx equals x plus 1 over y, and you have -1, 2. And it says, is this a local maximum, a minimum, or neither? So you remember this question from quizzes and so on. Now, the first derivative, if I put in -1 for x and 2 for y, the answer is 0. That's awesome. So it can be a relative max or min. Then we need to do the second derivative. Now, the second derivative, I need to do the quotient rule. It's not given to me. So the quotient rule is the bottom times the derivative of the top. The derivative of x plus 1 is 1, minus the top times the derivative of the bottom. That's just going to be y prime. And then the bottom squared. Now, I'm going to do the same work. I'm going to plug in -1 for x and 2 for y. So there's a y, that's 2. There's an x, that's -1. And then notice that y prime at that point, we already said y prime at that point equals 0. So the first derivative at that point, we know the answer is 0, so we just plug it in. And then y squared, well, the y is 2, so 2 squared. So if I simplify this, I have 2 times 1, that's positive. This whole part here on the right is going to be 0. So you have a positive over positive. It ends up being 2 over 4. But the whole point is it's positive, which means it's concave up. So it's 0, concave up. That means -1, 2 is a relative minimum because it's concave up. It's a bottom point. Yay, a good question. So let's not be bothered by 8. just keep going forward with number 9. All right, number 10. Number 10 says find the AROC, the average rate of change, of g at x equals x to the fourth minus 2x cubed plus 4x squared minus 1 from 0 to 2. Now to find the AROC, I need 2 points. These are my x coordinates. What I still need to find are my y coordinates. So if you plug in 0, 0, 0, 0, you're left with negative 1. If you plug in 2, this will take a little bit more effort, but you can do it. And then simplify it. So there I am. So I know that 0, negative 1, that's great. Plug in 2. 2 to the 4 is 16. 2 cubed, 8 times 2 is also 16. That's nice. 16 take away 16. 4 times 4, that's 16 minus 1. So 16, you're left with 15 at the end. So here are your 2 points. Can you find the AROC with those 2 points? So that would be y2 minus y1, x2 minus x1. So that's 15, subtract negative 1, 2 subtract 0. So that's 16 over 2, which is 8. That's the AROC. All right, number 11. Number 11 is the toughest one, but we'll do it together. So in number 11, a person is flying a kite, holds a string 4 feet above the ground level, and the string is let out at that rate. So we have a person that's holding a kite. We know the string, that is 4 feet above the ground where he's holding it. The string is let out at a rate of 3 feet per second as the kite moves horizontally across here. Or the height in terms of moving it horizontally there. So I'm going to draw a right triangle that describes that movement of that kite. So can you see that right triangle? Ignore this line here. So can you see the kite moving horizontally? What else do I know? That the kite moves horizontally at an altitude of 50 feet. That means from the ground the height is 50 feet. There's no snag. Find the rate the kite is moving when the string is, so there's a string, 60 feet. All right. So if this is 4 and this is 50, this must be 46. You just subtract the two to know that distance there going up. Now, we need an equation. This is called a related rate problem. So we need an equation that describes a right triangle. So our friend, Pythagoras, a squared plus b squared equals c squared. It doesn't really matter what's a squared or b squared in this case. So a squared, let's say, is 46. We don't know b, but we need to solve for it, and c is 60. So if I get b by itself, you would go subtract 46 squared. I don't have my calculator yet. Take the square root. That's what you would put in your calculator. The exact answer is the square root of, what is it, 1,484. Also 3 root something, or 2 root 1484, is that right? No. Just the square root of 1484. So put that in the calculator to get what b equals. Now we're going to go back to our old friend. We needed that value because we weren't given it, but now we need to go back and then understand and take the derivative of this in order to do it, but the derivative with respect to time. Now, if there's anything that's constant in the problem, we can plug it in before the derivative. So is there something that doesn't change over time? So I want you to notice the altitude doesn't change. So this 46 does not change. So I can plug 46 in right away. That stays all the way through the problem, the same height all the way through. The b is going to change, so I need to keep that b in there. So as the kite moves, b is going to get bigger. And then c, the string as it lets out, is also going to get larger. So c needs to stay in the equation. So I'm going to take the derivative of this with respect to time. So the derivative of 46 squared is 0. The derivative of b squared is 2b. And then db by dt. And then c squared is 2c dc by dt. Now I'm going to plug in. So b is root 1484. db by dt, that's b is the kite moving. That is actually my unknown. At what rate is the kite moving? That's the b by dt. The c is 60. the rate the string is moving out at. That's in the problem. So in the problem it says 3 feet per second. So that is dc by dt. 3 feet per second. Now all I have to do is get dB by dt by itself and use my calculator. So it's 2 times 60 times 3 divided by 2 times root 1484. And what is that? Approximately, rounding to 3 decimal places, I get 4.672 feet per second. That's the rate the kite is moving at, exactly when it's 60 feet up. Number 12, easier problem. So here, this is like the highest level type of problem, and then 12 is more of a basic problem. Number 12 says, does f at x equals the absolute value of x minus 4? Does it satisfy the MVT between negative 10 and 10? Well, we know that this is a v-looking function, and that when you take what's inside equal to 0, at what x value do you have that corner? And is that in my interval? Yes. So does it apply? No, it doesn't. Why? Because at x equals 4, what's happening? Not continuous or not differentiable? And so the answer is not differentiable. It is continuous, but you can't take the derivative at that corner. So that's why the MVT does not apply. All right, that's 12. A couple more left, 13. So you're given a function, 2x cubed minus 12x squared plus 10. It says, is concave down in what interval? In fact, so this is, again, a low-level problem. First derivative. And then take the second derivative. Equal to 0. There it is, sorry. Solve for x. Add 24, divide. You can see x is equal to 2. Do that at 2. And you can see when you plug in a number smaller than 2, it's negative. When you plug in a bigger number than 2, it's positive. So where is it concave down? It's concave down between negative infinity and 2. Concave down. All right, I'm just going to stop it for right now.